Hello folks, today we're going to work on ions. But before we do that, we need to review this one question. What is a neutral atom? So neutral atoms are what we studied in the beginning, the basic proton, neutron, electron, the stuff we learned the first time around. Okay? So as you know, there are an equal number of protons and electrons in a neutral atom. There's no overall charge, so we know that they have to have the same number of positives, which would be your protons, and the same number of negatives, which would be your electrons. So if we look at this beryllium as an example, you'll see that beryllium has 4 protons, it has 4 electrons, and if you take those 4 positive charges here with the 4 negative charges here, you'll see that overall there's no charge, there's just 0. It balances out. Okay. So remember, neutral atoms have no charge, they have the same number of protons and electrons. Okay, talking about ions. The easiest way to introduce this is actually without looking at science. So we're going to use these little red and green dots right here. You'll notice there's 5 red and 5 green. And we're going to assume that 1 red and 1 green cancel each other out. So if we have 5 red ones right here and 5 green ones right here, our net color is neutral, right? When 1 red cancels out 1 green, 2 red, 2 green, etc. So right now, there is no net color. If we take away 1 red one, so now we have 1, 2, 3, 4 red, and 1, 2, 3, 4, 5 green, our net color is going to be 1 green. We have 1 more green than we have red. Let's take away 2 red ones. So now we have 1, 2, 3 red, and 1, 2, 3, 4, 5 green. Now we have 2 more green than we have red, so our net color is going to be 2 green. So now we're back at 5 red and 5 green. Okay, so 5 red over here, 5 green over here. Net color, neutral, there is no net color. They all cancel each other out. If we add red ones, so now we have 1, 2, 3, 4, 5, 6, 7 red, and 1, 2, 3, 4, 5 green. Now we have 2 more red than we have green, so we would say that our net color is 2 red. If we look at it in this arrangement, which is more true to an atom, we still have 5 green and 5 red. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So this is still considered neutral, but with this arrangement, keep in mind that your green dots are essentially trapped inside the red dots. So only red dots can be added or taken away. If we wanted to make more red, we would have to add red. We would not be able to take away green dots. Okay, so just keep that in mind. Red can be added or taken away. Green has to stay the same. Now, if we have 1, 2, 3 red ones and 1, 2, 3, 4, 5 green ones, our net color is going to be 2 green because we have 2 more green ones. So here we're back to neutral. There's 5 red and 5 green. If we add some red, so now there's 1, 2, 3, 4, 5, 6 red, and remember still 5 green because we can't touch them. Now our net color is going to be 1 red. We have 1 more red than we have green. Okay, looking at this example, notice there's still 5 green ones in the center. Right here, there's still 5, but now we have 1, 2, 3, 4, 5, 6, 7, 8 red. So now it's going to be a net of 3 red because there's 3 more red than there are green. Okay. Looking at this one, we still have 5 green, but now there's only 2 red. So now, if you take a look, there's 3 more green ones than there are red ones. So our net color is going to be 3 green. Keep in mind, we didn't add any new green ones here. All we did was take away red ones. So in order to understand what ions are, we need to know a couple things. We need to know that the particles that make up atoms have either a positive charge or negative charge. Okay, we call these guys protons, we call these guys electrons, but you have to have both. And here we represent that with some more dots. In this case, this orangish color is negative, this blue is positive. And if you have the same number of each, they cancel out, right? 1 positive and 1 negative equals 0. There is no net charge. So as long as you have the same number of protons and electrons, so this being an electron, this being a proton, you're going to have a neutral atom. Those two charges will cancel out. Again, if you're looking at this, I just want to reaffirm that equal number of negative and positive means you have a net charge of 0. Okay, there is no charge. There's no net difference. Just a reminder, which we've said before, but the positive particle in an atom is called a proton, represented by a little positive sign. And remember, the negative particle is called an electron, represented by a negative sign or a minus sign. Okay, in an atom, protons are at the center in what we call the nucleus right here. Electrons are on the outside in an electron cloud or electron shell. So we had in here green dots on the previous example and red dots on the outside. When it's set up like this, like a real atom, you cannot change the number of protons. Okay, those have to stay the same. The number of electrons, though, you can change, so you can take away these guys out here on the edge. Again, protons are protected. You can only add or take away electrons. And the reason for that is because if you change the number of protons, you're actually changing the element itself. So if you take a look here, you'll see all of these atomic numbers. So sodium is 11, magnesium 12, aluminum 13, silicon 14. So if you look, 11 is the number of protons that sodium has. If you add a proton, now you have 12 protons. Now you're looking at magnesium, not sodium. If you look at magnesium, there's 12. Let's say you wanted to add a proton to get more positive. That would put you at 13 protons, which is aluminum. Okay, so just keep in mind, you can't change the number of protons. You can only change the number of electrons. So if we're going to look at this example, this is a normal atom. Right now it's neutral. You'll notice in the middle here, there are 5 protons and 5 electrons. Okay. So again, right now, the net charge is 0. It's totally neutral. This is a regular atom. If we want to look at something different, we add an electron here. So again, 5 protons, you can't touch those. They stay the same. But now there's 1, 2, 3, 4, 5, 6 electrons. So now we're going to look at a net charge. If we have 6 negatives and 5 positives, our net charge is going to be 1 minus or negative 1. Okay, so if we go back to our neutral example, so you can see, again, here there are 5 protons and 5 electrons. Let's look at this option. So there's 5 protons, and now here there's only 3 electrons. So our net charge, if we have 5 positives and only 3 negatives, the net charge is going to be 2 plus or positive 2. Remember, you cannot add or take away protons. All you can take away or add is electrons. So this example, since you have more protons than electrons, you're going to end up with positive 2 charge. Okay, so when you are removing electrons, so here on this side you went from 5 and then over here to 4, you're actually going to end up with an ion that is positive. Okay, so if you look over here at the left, 5 and 5 cancel each other out. Over here you have 5 positives and 1, 2, 3, 4 negatives. So you end up being more positive. If you're looking at adding electrons, so again, this side has 5 and 5. This side has 1, 2, 3, 4, 5, 6, 7 electrons and only 5 protons. When you're adding electrons, you're going to get more negative. Okay, so this example over here is neutral, again 5 and 5. Over here with 7 electrons and 5 protons, you're going to end up more negative because there's more negative charges that were added. Okay, just to recap, an atom with a positive or negative charge is called an ion. And atoms that have no charge, they are without charge, are simply called atoms. If the atom has a positive or negative charge, it's considered an ion. So again, atom with no charge is called an atom. Atom with a charge, either positive or negative, is called an ion. And one more thing to remember, only the number of electrons changes. Okay, you can only add or subtract electrons. You cannot add or subtract protons. Again, down here at the bottom, the number of protons in an atom never changes. Remember why? If you add protons, now you're changing the actual element, not just its charge. I hope this helped. If you have questions, please let me know.